Hello, ladies and gentlemen. I'm sorry that this is getting posted late. It's currently 5:48 and I haven't left BT yet. And before I go home and see my family, I wanted to give you guys a little bit more help on this. I think that you're struggling, and I think doing a little bit more algebra might actually help things a little bit. So, remember this question. This is the first example. And what we did was we looked to see if they were parallel. I think we determined that the normals are in fact not scalar multiples at all. We'll take a quick look at them. Okay, so looking at those, if I multiply this to get, well, look at the 1, it's easier. If I multiply the 1 by 4, I get the 4. So if I multiply 2 by 4, yeah, it doesn't give me the 3. If I multiply the 1 by -2, if I multiply the 2 by -2, it doesn't give me the 1. So these two are not scalar multiples. These two are not scalar multiples. If I multiply this 1 by 3 and then multiply the -2 by 3, I don't get 4. So none of them are scalar multiples. So no planes are parallel, since no normals are scalar multiples. So what that means is that we're down to case 3. So we either have this type of situation with no point of intersection, or we have maybe this, maybe that can represent a line of intersection. And this will definitely represent the point of intersection. Okay, so it's one of those three. So what we can do is check to see if normals are coplanar. So we do the triple scalar product. And with this one, we come up with that they don't equal 0, which means that they're not this one, they're not this one, they have to be this one. So therefore, a point of intersection exists. And it's only a point of intersection, not a line of intersection. And that's where we left it. But you know what? I think you guys would do well to start seeing some of the algebra. Let's say you needed to find the point of intersection, because I'm going to ask it on your test. Determine the point of intersection. So, how are we going to do that? I have 3 equations. Okay, we have 3 equations, and I want to be able to solve those 3 equations for a point of intersection between all 3. So what I'm going to do is I'm going to take a look at these, and I'm going to set them up into groups. I'm going to look at plane 1. I'll move this up so you can see it. Plane 1. Well, you've got the sheet in front of you, so I'm going to move that up so you can't see it anymore. But plane 1 was going to be 2x plus y plus 6z minus 7 equals 0. And I'm going to look at plane 3. Okay, so plane 1 and plane 3, because I notice what I'm going to do is I'm going to get rid of x. It's just easier. If I start with this one, I can multiply this one by 3 to get rid of that x. I can multiply this one by 2 to get rid of that x. You can start anywhere you want, but the idea is to work with groups of 2 and eliminate the same variable. So looking at this, that's plane 1. Plane 3 is going to be x minus 2y minus 4z minus 9 equals 0. So now what I want to do is I want to eliminate for a variable. The variable I'm choosing to eliminate for is x. So I'm going to multiply the bottom one by 2, which is going to give me 2x minus 4y minus 8z minus 18 equals 0. And the top one just comes across. 2x plus y plus 6z minus 7 equals 0. Now, using elimination, which should be something that you're fairly good at, I'm looking for my red pen. That's going to give me 0x plus 5y plus 8, 9, 10, 11, 12, 13, 14 z, and plus 11 equals 0. Now, what I want to do is I want to do the same thing with two other planes, and I want to eliminate for x again. No sense eliminating for something other than x. So I'm going to work with plane 2, which was 3x plus 4y plus 3z plus 8 equals 0. And plane 3 again. Why? Because it's easy with the x. Didn't have to. Could have done anything else that I wanted. I choose to get rid of the x again. And so I'm going to multiply this one by 3. And it's going to leave me with 3x minus 6y minus 12z minus 27. The top just comes across. 3x plus 4y plus 3z plus 8 equals 0. All right. Subtract 0x plus 10y plus 15z plus 35 equals 0. So we're going to call this equation 4, and we'll call this equation 5. Notice that both equation 4 and 5 are in terms of x and y's. We could reduce this. You'll find out that it won't help us any if you do it in this particular case, but we could reduce this. This could become 2y, 3z plus 7 equals 0, but we're going to leave it the way that it is now. We're going to use 4 minus 5. We're going to use 4 and 5 anyway. Let's not say that we're going to minus them. Let's see what we get for 4. We're going to get 5y plus 14z plus 11 equals 0. You're going to get 10y plus 15z plus 35 equals 0. I'm going to multiply this one by 2. 10y plus 28z plus 22 equals 0. This comes across. 10y plus 15z plus 35 equals 0. Okay, we're going to eliminate again. We get 0y. 28 minus 15 is 13. 22 minus 35 is negative 13. So we end up with z equaling 1. Okay, I'll move that up so you can see it. There we go. So what I'm going to do is I'm going to take that z equals 1, and I'm going to plug it into either 4 or 5. So sub into 4, which is going to be 5y plus 14, 1 plus 11 equals 0. So 5y equals negative 25. Just checking that. So y equals negative 5. Now we're going to take z and y and plug it back into one of the originals. So why not plug it into plane 3? So now it's going to be x minus 2 minus 5 minus 4, 1 minus 9 equals 0. So it's going to be x plus 10 minus 4 minus 9 equals 0. So that's negative 13, so x equals 3. So your point of intersection is going to be 3, negative 5, 1. Now if you want to check to see if that works, that point should satisfy any of the 3 equations. So let's pick one of them. I'll pick the second one just because I haven't used it for a little while. The second one looks like this. It is 3x plus 4y plus 3z plus 8 equals 0. Let's check. Point of intersection lies on plane 2. So it'll be 3 times 3 plus 4, negative 5 plus 3 times 1 plus 8. Now if this works out to be 0 equals 0, then we're good to go. Sorry. 9 plus 3 is 12, plus 8 is 20. So therefore, that point lies on plane 2. And we could continue our check to see if it lies on plane 1. Right now I can hear the voices in the background. Do we have to check? No, I guess you don't, but you better be right. So it's 2, 3, minus 5, plus 6, 1, minus 7. 6 minus 5 plus 6. Uh-oh, are we in trouble here? 6. Did I write down? It's 3, negative 5, and 1, right? So 3, negative 5, and 1. Plane 1 is 2. Y plus 6z. So it should be 6. That's a problem. What did I do wrong? X is 3. Y is negative 5. Z is 1. It should equal negative 7. So it should be 6, negative 6, negative 5,